Okay, so yesterday when we did composition, you actually didn't do f of g of x. You always only did f of g of a number, and you found the domain without actually finding f of g of x. So the other thing that we have to do is how do I actually find the new value f of g of x in terms of x? Sometimes kind of easy to do, sometimes a little more complicated with fractions and common denominator stuff. But again, we're doing this because it's going to help us prove that two functions are inverses. That's what section 6.2 is about. So that's why we're doing that. Oh, we're doing this yesterday, today, in the future. All right, here we go. This is terrible because you have to do parts A, B, and C. Ugh. This could be why I took 2 problems off the homework that I recently assigned because it was so much work. Just like we did yesterday, but notice there's no number after it. So if it says find f of g, g of f, and g of g, and state the domain of each composite function, it's not as simple as finding f of g of 2, right? You actually have to take one function in terms of x and plug it into the other one. And so I think I left a blank. Maybe I didn't. Did I leave a blank thing somewhere? Maybe on the next one. Because the next one with the fractions. Oh, such space here. But I'm just going to do this. If I do f of g of x, and again, I automatically change that composition to a parenthesis. Some people show a lot of work. Some people don't need to show a lot of work. What am I doing? I'm going to take g of x, which is not a number now, it's a function, and I'm going to plug it in wherever there's an x in f of x. So I say start with the inside function. You can replace g of x with what it equals, which is 3x. And just like yesterday, except for yesterday it was just like 3, right? We're going to take that and we're going to plug it in right here. So everything else stays the same except for x is going to change to 3x plus 3. Right? That's the idea of function notation, being able to plug a number in, and then I just work it out. 2 times 3x is 6x plus 3. And again, some people aren't going to need all that work, but I feel like if you're confused on what to do, that's like the most possible work you could show, showing where that comes from. And that's your final answer. If I took g of x and I plugged it in for f of x, this would be the new function that I get. And so now we're just going to go the other way. What if I did g of f? And remember, that's going to be something different for the most part. So if I did g of f of x, now f is the middle function, and I'm going to take it, and I'm going to plug it in everywhere there's an x in g. So again, if you want to show your work, step 1, start with the inside function, which is 2x plus 3, and then do g of that. Just like g of 2, you would say is 3 times 2. If I want to do g of all of this, I'm going to replace x with all of this, 2x plus 3. The problem that people have is they just overthink x. There's an x already, and then I'm putting it with another x. But you just got to kind of get past that. You're just replacing x with what's in the parentheses. And now on this one, we're going to give the 3 to everything. So we get 6x plus 9 as my final answer. Questions about that? Cameron. Oh yeah, we'll get there later. Actually, we could do it right now. So here's the difference about domains. When you're talking about the domain, instead of having to do all the things from yesterday, you can just take into consideration the domain of the inside function and then the domain of what's left, right? Here's what's super great about this problem. What's the domain of 2x plus 3? What's the domain of 3x? So what's the domain of all those compositions we're going to do? Oh my gosh, why couldn't the unit test be that easy, right? So I can say the domain of this is negative infinity to infinity. Number 2, we'll talk about the domain because it's not all real numbers. If you have an x in the fraction, if you have a square root, the domain is not all real numbers, and then we have to do more work. G of g, also g is all real numbers, so if I do g of g, it's still going to be all real numbers. But it's the same idea, only I'm going to take g of x, which is 3x, and I'm going to plug it in for this x value. So I'm just going to replace that x with g of x, which is 3x, and I just get 9x. And again, the domain is all real numbers. Only life were that simple all the time, right? You might think that's not simple, but look at the next one. And guess which type of problem is going to be on the unit test? This one or the next one?
Probably the first one.
Probably you're right. Why are fractions so bad? I don't know, because we're just not good at simplifying fractions and common denominators, and I don't know why we're so bad at it, but we tend to be scared of it and we run away from it. And we're going to take a fraction and plug it in for a fraction, and so we got to be able to simplify it, get common denominators, and I'm not going to lie, it's not that pretty, which is why I left you a blank slide, because to do A, B, and C, you're going to need a little bit of room on here. We could do the domain of this before we even start, just like we did the domains yesterday. But I want to show you the other alternative of when, if you actually already are finding f of g, I want to show you how we can use the answer to help us find the domain. Okay? So, let's start with A, and let's do f of g of x. I will tell you the domain part of you have to exclude what the inside function can't be is still true. I still have to say right away, looking that g of x is the inside function, what do I know I can't have in this function? One, the inside function is g, so I would have to say I have to exclude what g can't be 1. So I still have to think about that. I'm going to wait to the end, but that part's still true. But the crazy middle part, if you hated that part, I'm going to show you a shorter way to do this. So I'm going to take g, which is 4 over x minus 1. I'm going to take that fraction, and I'm going to replace it right here. Which means I'm going to have a fraction, and I'm going to throw a fraction in the bottom. That's exciting, right? So I'm going to get 1 over, instead of putting x, I'm going to put this. I'm going to put 4 over x minus 1, and then I still have plus 2. Questions on where I'm getting that part? The fun part is we can't leave our answer like this, right? We're not going to leave a fraction in a fraction, which means that we've got to remember how to get common denominators. We've got to remember how do we divide fractions. So then it just becomes simplifying it. Do you agree this is 2 over 1 right now? So if I was going to simplify this into a common denominator, do you agree my common denominator would just be x minus 1? Or maybe we could do like we did in calculus. Never mind, I'm going with this. We couldn't multiply the top and the bottom by x minus 1, but it's right. I'm going with this. And if I want this to be x minus 1 and it's already x minus 1, do I have to do anything to this 4? No, so I'm just going to go ahead and leave it a 4. And notice I've made one big fraction already because the goal of a common denominator is you make one fraction. So I kind of always just do it at once. If you want to separate it and then put them together, you can. But this is going to be a long enough problem, so that's why I do it all at once. Plus, this one does not have x minus 1. It only has a 1, but that 1 does not count as this one. Do you agree with that statement? Like, I need an x minus 1 on the bottom, so the only way that I can put it on the bottom is if I also multiply the top by x minus 1. And I'm just going to distribute that 2 to that, so I'm going to get plus 2x minus 2 all over x minus 1. Oh, I bet you've not left room for what's left up there. There's still a 1 up there, right? Should have written that first. Ah, algebra, it's all coming together. If I simplify this, 4 minus 2 is 2 plus 2x, and then I still have that x minus 1. Here's the big thing. We don't leave fractions in a fraction. We don't leave this. This is a complex fraction. Not complex imaginary, but complex meaning that it's complicated. What do you do when you divide fractions? What's that the same as? Multiply by the reciprocal. And so this 1 was like my top. So I'm going to leave the 1, and I'm going to multiply by the reciprocal of this. So I'm going to move the x minus 1 on the top, and the 2 plus 2x on the bottom. I just combined it, 4 minus 2. Which is just a 1 on the top, which means it's really just this as my answer. Do you agree with that? So I think I'm going to go back over here, and I'm going to say f of g of x, when I finally simplified it all, I get 0 in my denominator, so x is not negative 2 divided by 2 is negative 1. That's the second step that you had to do yesterday, that you can still do that way. You can still tell me that x can't equal negative 2. You can set that equation equal to negative 2 and solve it all out. But if you've already done all this work, that's the same answer that you would get. So you see how if you just find f of g, then you can just say what that can't be. But you still have to remember to exclude what g of x can't be. And what can't g of x be? Positive 1. So I also have to say that x can't equal 1, because the same step of yesterday, you have to exclude the inside function values. So my domain is going to be everything except for plus or minus 1. On the unit test, when they ask you to find the domain of f of g, they don't ask you to find f of g, which means if you know the way we did yesterday, you can do it that way. Some people don't like that way. It's too confusing for them, so they actually just do this work, and then they do the domain. Both ways work, it's just whatever makes the most sense. For me, if I have to find it, I'm going to do it this way. If I don't have to find f of g, I'm going to do it the way we did yesterday. Oh my gosh, this is only part A. Let's do another one. Angel.
Okay, I spaced out whenever you were talking, whenever you went from 4 plus 2 is minus 2 to 2 plus 2.
I just added 4 minus 2 to get 2. So now we need to do g of f. If I'm doing g of f of x, what value do I have to exclude from my domain right away? You have to exclude the inside function. So now that f is the inside function, I have to say x can't equal negative 2. And if you want, say that right now. X can't equal negative 2 to remind yourself. And then after you do it, whatever x can't be on the bottom is also excluded. But now I'm going to take f of x and plug it into g of x. Oh, this is annoying. 1 over x plus 2. And again, I'm going to get a fraction. So 4 over 1 over x plus 2. What was it? Minus 1? Minus 1. If you do the substitution correctly, where you take f of x and plug it in for x and g of x, you should get this. And then again, it just becomes getting a common denominator. And hopefully after doing this 3 times in our notes, because we have to do f of g, g of f, and g of g, you'll be reminded about common denominators. And again, the really nice part is I think every one of these problems, this is just a number. So you just put it over 1. So my common denominator is going to be whatever that is. So I need x plus 2 in the top and the bottom. So I still have my 4 on the top. And then if I'm going to write this all over x plus 2, I don't have to do anything over here. So that's going to stay a 1. Be really careful on this side, though. This is like a negative 1 that we're giving to both of these, right? So really easy to make a mistake. But this actually is going to become minus x minus 2, because I have to distribute that negative to everything. Really stinks if that's the mistake you make, right? Or like yesterday when I divided the wrong way. That really stinks too. Questions on where I'm getting that? And then I'm just going to flip it up, and I'm going to simplify at the same time if you're okay with that. I'm going to leave my 4. I'm going to change division of a fraction to multiplying by the reciprocal. So that means I get x plus 2 on the top. And again, I'm just combining like terms here. 1 minus 2 is negative 1. So however you want to write that. Negative x minus 1, negative 1 minus x. What do I do with that 4? Multiply to the top, and I don't care which way you do it. Distribute it, leave it in the front with parentheses. I don't care. Both are acceptable, right? Like you could leave it as 4 times x plus 2, or you could write it as 4x plus 8. It's the same thing. This would be g of f of x. Can you tell me what other value is excluded from this? Yeah, it's kind of tricky with all the negatives, but if we set that not equal to 0, then we would add 1 over and then divide, so it's actually negative 1. And we also had to exclude negative 2. So my domain is everything except x equals negative 1 and negative 2. Not the most fun thing to do, but not the worst thing to do either, right? Better than dividing synthetic division with imaginary numbers theory. So the last one's a g of g. It's the same idea, only we're going to take g and plug it into g itself. But it's going to look just the same. You're going to have that complex fraction. You're going to get a common denominator. So why don't you take a minute, I'll set up the top part, like plugging it in to make sure you have the same thing if you're not sure about it. But see if you can do the common denominator and get it flipped around before I do it, before we go on to the other thing. Go page this so that I can see. So C is G of G, so that would be 4 over x minus 1 minus 1. Right, I think that's where it should be if you plug g of x into g of x, and then see if you can get a common denominator, watch your negative, ask me a question if you have it. Three problems in one. I agree. I feel like taking college algebra and calculus together is really helpful because I feel like college algebra makes you better at the algebra and calculus, is what I think. Because we do review all of this stuff. Whereas the calculus people, they just get my quick review of it in class. Of, remember to do this, compounding, like I put Rachel Newdeck doubled up last year and did both, and I felt like she had a leg up on some of the algebra. The other people, I just vaguely remind them of, come on, we know how to do this. Yeah. And next semester, taking the trig class will brush your skills up on all that trig stuff too. So. Right, so on the bottom here, I get 4 minus x plus 1. Did you distribute your negative?
Yep.
So I get 4 times x minus 1 over 5 minus x. So g of x is going to be, and I'll distribute this time, 4x minus 4, or leave it parentheses, I don't care. And on the bottom, 5 minus x. Questions on where I got that? What can x be in this problem? 1, because we have to exclude the inside function, which happens also to the outside function. We have to exclude 1. And then we also have to exclude what makes the answer undefined, which is 5. So that second part, you can do this way, or you can do the way we did yesterday if you don't actually have to find it. Yesterday we didn't find it, which is why I didn't show you how to find f of g yesterday, so you had to do it the other way. But now that you know how to find f of g, you can do it this way. No, we would say, if we wanted to find this second number without finding it, we would say, what can't this be? Which is 1, and then we set this equal to that, and then we solve that problem. Like, where does that equal 1? And we exclude that value, but you will get 5 out of it. Like, that's where that comes from. It's just doing it without actually doing all the work. I will tell you, last year, the majority of people just decided, even if it didn't say find f of g, if it said find the domain, they just found f of g, and then found the domain of it, because they found it to be less confusing than trying to remember what he set it equal to and solve it. And so, I'm not opposed to you doing that. I just wanted to show you, because I know there's a question on your unit test, like the ones from yesterday, that just said find the domain. So I thought it would be important to show you how to do that. The other thing that we're doing today, I kind of like. I find it not so bad to do, but it's one of those things I feel like you have to kind of see a little bit. And that's called decomposing functions. That's kind of a fun word, decomposing. It kind of makes you think a little bit of if they give you a problem and they tell you that it's a composite function, could you break it apart and like what would f be, what would g be that would give me this composite f of g? That's what it means by decomposing. And sometimes it's kind of you have to see it, but remember that when you do f of g, you should be looking for an inside and an outside function. So for number 3, it says find functions f and g such that f of g equals h. So they're telling you that this is the composite function. They want you to tell them what is the outside function, what is the inside function. And it's one of those things that if you don't see it right away, as you do some of these, you'll see it a little bit more. Because for me, when I look at this, do you see something that's on the outside and something that's on the inside? Yeah, like for me, it looks like x squared plus 1 is on the inside. So what if I say g of x is x squared plus 1? What would the outside function have to be? X to the 50th, because that would be out here. And these are really great because you can check your answer. If I took this problem and did f of g of x, if I took this and plugged it in for x here, would I get what h of x equals? Yeah, and some people are really, really good at it, like they can see it right away. Some people, you got to practice a little bit, you got to really think about it. But that's what it is. And again, on your unit test, there's a question that asks you to break apart a function. There's really more than one right answer. Like, people can come up with other things. Let's see if we can think of another. What if I made g of x x squared? Could I do that? If I want to just replace x with x squared, I think I could write this as x plus 1 to the 50th. Would that also work to give me that function? I could take this and plug it in for here. Here's the cheating way. You could always make the inside function x, and then the outside function is what's just there, right? That's cheating. You're not allowed to do that. Right? Like, what if I said g of x equals x? What would f of x equal? X squared plus 1 to the 50th. Right? Like, if you made the inside function just x, and you replace x with x, the outside function stays the same. That's cheating. You're not allowed to do that. In pre-cal, when we do this, on the test I say, one function may not be x, and I think the unit test says the same thing. One function may not be x. That's cheating. You gotta think a little bit outside the box for that. But there is more than one right answer, which is kind of exciting sometimes when I grade your test, because I have to think, did it work? I have to check it. So, I think I just have another one of these. Don't yell it out. This one's a little bit harder maybe to think about outside and inside function. If there's parentheses, or power on the outside, or a square root, I find it a lot easier, like it jumps right out at me. But what about something like this? If I want to think of two functions that when I plug one into the other, then I would get this. Anybody want to give an idea, Bobby? What do you think?
1 over x.
For f or g? Inside or outside, right? If it's f of g of x. Which one's outside? Well, how about let's write your two functions down and then we'll figure it out. 1 over x, and then what's your other one? I don't think I can get 1 over x plus 1 out of that. Because if I take this and plug it in for this, do you agree that that just equals 1 over 1? And I don't have an x to plug that in there. You're close. You're on the right track. If 1 over x is my outside function, what could I plug in for x that would give me 1 over x plus 1? Could g of x be x plus 1? Oh, this is like mind-bending tricks, right? You're like, oh, my head hurts. But that's true. I could now take that and plug it in for that, and I would get that. So why they have you do this is it's harder to go this way sometimes, because you have to think backwards of how would I break this apart. I don't know. I mean, I guess there's another one. If you just pick x, right, you're not allowed to do that. But I think that one's kind of, like, you have to pick that almost, unless you want to get fancy and, like, add and subtract terms. You could always get fancy on that. How do you feel about that? You want me to do another one? I don't care. What if I said h of x equals the square root of 2x plus 7? the outermost part of this function? The square root. So what if I said the outside is square root? Let's just leave it alone for right now. The inside, this is all inside the square root to me. So what if I said 2x plus 7? I'm not cheating because the x is not one of the answers here. But what would I have to put up here? I can't just put a square root sign. It has to be the square root of x. That's not cheating because the square root of x is not x. And then that's true. I could take this and I could plug it in. Do you see the outside? Like outside is square root, inside is this. We'll see. I gave you a few on your homework. Those are the ones that don't really take work to do, but they do take a little bit of brain work. The other ones are the ones that take work to do. So I actually want to give you some time to work because this does take some time. 30, not so bad. It's not a fraction. 33, not so bad. It's quadratic. 36 is like the one we did number 2 in our notes with the fraction. And then 47, they just ask you to do f of g and g of f and see if you get x back. We're going to talk about that tomorrow. That kind of leads us into 6-2. And then 53 through 56 are the breaking apart the functions. Okay, so really these three are the ones that you have to do the parts A, B, and C on. But they're not all fractions, so they're not so bad to do. But you do have about 10 minutes, so start on it, ask me questions if you have it. The board is not true anymore because we are not on 6-2 today. We will do 6-2 tomorrow.
So wait, are we on track?
We are off track, but that's okay.
Someone has asked me, where did we go Friday?
We're not having a quiz on Friday anymore because we're off track, right? Like we were supposed to do 6-2 today.
So are we at Mercy?
So I don't know really what we're doing. We might, but I have to look at 6-2 notes and see if I can condense it down to one day. Because if I can, then yes, we'll do a review on Friday and have a quiz on Monday, which means on Tuesday I'm not here, but I will record some notes for you because I really want to get through this stuff as fast